Hello, everyone, and welcome again to another session at LRVS. And for this session, I'm really happy to introduce Andy Gailey, our friend from the UK, and he's going to be talking about the maintenance investment conundrum. And just before we get to that, I want to remind you, here's the code for this session. So use it in the play to win section of the app. And without further ado, here's Andy.
Hello, today we're going to take a look at a common conundrum that exists in almost all businesses that I've come across. That is, how much should we really be investing in our overall maintenance strategy? I want to talk about the challenges of understanding and articulating the great value that a maintenance function can deliver. What are the constraints trying to get that job done? And more importantly, a method of gauging and measuring that we are investing enough, not too little, not too much, to look after our assets in the way that we require. I call this the maintenance investment conundrum, and we'll see later why it is such a conundrum. As you can see, I'm a mechanical production engineer by trade. My formative years were spent in the manufacturing industry with gas turbines, transmissions, defence work, press tool work, and also with a few years spent in the motorsport and shall we call kind of racing environment. I was able to take a change of direction in the mid-1990s when I answered a strange job advert that was just said they were looking for time-served engineers that were up for a challenge. I found myself, after a couple of months of selection, working for PepsiCo International in the snack food industry part of the business, and here in the UK it's part of Walker's Snack Foods Limited. During the last 9 years with them, I spent time developing, then refining the predictive and the lubrication strategy for what was and still is, I believe, the largest snack food plant in Europe. In 2015, I formed UPTIME Consultant Limited as an independent production engineering consultancy to bring this wide range of maintenance thinking and tools to a wider audience, including the automotive sector, utilities, water industry, still food as well, and some other SMEs and other businesses. Basically, I think if I can help somebody or a business get to a better place, then my aim has been achieved. I'm a great believer as an engineer that there's always a better way. It's just that we haven't found it yet. Probably all understand that there are different types of maintenance that are carried out in different business, depending on what your strategy is. That's if you have one. I see these fall into three distinctive categories. There's the completely reactive one, where the business waits for things to break and then it sends engineers out to try and find out what's gone wrong with the asset, and ends up spending quite a lot of time and expense getting those assets back online. The second one is one that it looks on the surface to be in control. The business can point to all sorts of planned maintenance routines they carry out. Sometimes they can hit quite a large KPI on those targets. But when you dig down, you find out that they're still having quite a lot of reactive failures, even though they're carrying out lots of planned routines and changing parts out on a time basis. So there's lots of check boxes and tick boxes, and people feel that they're doing the right thing, and some of the times that they're achieving KPIs because that's what the target does. It drives people towards achieving the KPI rather than driving the productivity of the business. There's one that's rarely seen, but one that I've worked in and had experience of, and that's where the engineers that were fully in a reactive mode or in a maintenance role kind of more diverse, and they become people that look to re-engineer or make things better They carry out continuous improvements on their assets. They'll look at assets with a critical eye and think, well, the OEM probably was constrained by budget, so they didn't probably know what was going to happen in this environment. So they have the time to upgrade, make these assets better for the uses they're being put to. And that usually makes expenditure work in a different way. It works in, it's more controlled, and it works in the betterment of the plant rather than the constant repair. They still have to go and repair a plant. Obviously we can't, we'd like to have a zero tolerance to unplanned downtime, but unfortunately it's just the way things are. We will always have things that break. The difference is those engineers go out and they have more time, so they do it in a quality way, and they make sure that they maybe do it so that it doesn't happen again or as frequently. So with these three scenarios, we have to ask ourselves some questions about what we want and what we can do. To understand the basics of investing in our maintenance function, then this might be the place to start. Hopefully we can shed some light on possible solutions in this short presentation. Number one is, does the business know why it actually has a maintenance function? And does it value the input that it can provide? The second one is, we need to know how much resource should we allocate to the overall maintenance budget? Does everybody understand in the business the benefits that maintenance can deliver if it's delivered correctly? Number four, hopefully there's a strategy or a plan as a guide or a benchmark, and that there's a target, there's an actual target to hit on that benchmark plan. This is kind of reiterating number two, but in this I talk about the three finites: how much time, money and other resource, including all important labour, should be invested. If you can answer all or some of the above, then it's a good starting point to get into solving your maintenance conundrum. Doesn't matter what sector you're in, if you've got assets and they're prone to failure, they need some level of care. This will change obviously across industries, and depending on what environment they're in, depending whether it's a very heavily regulated industry, a food factory that's all, the assets are all within the building mainly, will not be the same as something that's mining materials in the open. Things like nuclear power industry or those very regulated industries, their maintenance budgets are probably almost definitely going to be higher than, say, in automotive or food or in consumer goods. So what we need to do though, overall we're going to look at, for me, we're going to look at these automotive, fast moving consumer goods or food and beverage, those type of industries, because those are the ones I operate in mainly, and those are the ones I'm used to. So if we take a look at the three finites that all of these businesses are constrained by when it comes to our asset care, time, money and labour are these three finite constraints that we all have to work with when taking care of our assets. These are the three key ingredients, not just in maintenance but in operation and life as well. Time is a constraint that rules all of our lives. We generally work to the clock. We only have so many years in a lifetime, and it's the one constant we can't buy with money. There are always only 60 minutes in an hour, and there's only 24 hours in every day. The second constraint is money. Again, in life as in business, there's only so much money in the pot. Unless that's, of course, you're a government and you can print your way out. Budgets are always either under constraints or, in these days, they're tightening. Labour, I could have just said resources here for number three, but I think with maintenance, this is the main one that is under our radar and under threat. Not just from the shrinking skilled workforce that we see globally, but from demographics. The whole working population is on the decline. So this is the main resource that we need to take care of when we look at maintenance best practice. All of these three obviously work in tandem with each other. If we need to employ more labour, then we have to fund it with money. We have to use more time, then it costs us money. It all impacts our budget. So finding a balance between these is what we need to do, whichever way you look at it. Depending on where an operation finds itself, see where it is in its business cycle. So a few years ago, I had a meeting with somebody who asked me for a couple of hours of my time, and he'd just left the armed forces. So he was coming from the armed forces, where they obviously, some of their constraints were different to Civvy Street, and he was going to come out of REMI, which is the Royal Engineers, and he wanted to know how people in business think about maintenance and reliability and how they value it within businesses that are in the armed services. So I was able to share with him some of my experiences along the way, and it ended up with me sketching out on a napkin what I later called the chaos to control graphic, which is next. So as I alluded to earlier, businesses all operate in different domains when it comes to maintaining their assets. One of the tools I experienced that helped track a business that found itself in reactive chaos and work its way to the control phase was the use of capital asset replacement value, or CARV. Some refer to this as asset replacement value. Basically all it is a measure of what your capital assets are within your business. If we can apply the right amount of investment to these assets, then we can get really good outcomes. Remember, we have a link with money, time and labour, and these are shown in the vertical arrows. The percentage of CARV is shown on the vertical as well, and the horizontal is reserved for that state that a business finds itself in. In this, in the lower part of the range, it could be the planned end of a business, which is something I've experienced with a plant running down over about 12 months to the site closure. And in that case, obviously, the maintenance spend reduced over time over the last couple of years to zero. If you did the same, but to a plant was still going to be operational, and you don't know you're doing it, then you're ignorant to that happening, but you still end up with the same event, closure, the disaster effect. It's the worst scenario is if you are actually doing this by will and you're taking no avoiding actions, and that's what I refer to as the willful neglect. So there are some businesses that unfortunately do that. The benchmark figures that were mentioned earlier are represented with these figures of between 1 and 1.75% for a world class. So I think that if you're above 1.75 to 3.5, you're in the innovative and control phase, and if you are 3.5 to 6%, then you're in this kind of bit where you're taking proactive measures, and you're probably predictive as well with your assets. Anything above that, then you are heading for reactive chaos and some very uncomfortable areas there. So as you can see, those three constraints are there at present. They all increase as the CARV level, so the amount of money you spend as a percentage of your asset replacement value moves up. This demonstrates where a maintenance investment can make a real impact across multiple KPIs. And if I were to add one more aspect to it, I would think that we need to add safety to this as well. I didn't think of it at the time when I was drawing on the back of a napkin, but with as we see the control coming down and the unplanned downturn decrease as an effect, we will find that our safety scorecard will get better, because it's been proven over time that world-class facilities have a better track record with their safety. So we need to find out how much investment is right, not enough or too much, can both end a business, and you can imagine what willful neglect and ignorance can do. The good news is that after decades of data capture, quite a few international companies in many sectors have found this sweet spot between 1.5-2%. That's the right level. Change by sector, obviously, depending on regulation. So, for example, nuclear power facility is going to be a lot higher than a food factory. I always use the analogy of car ownership because something everybody understands. So we have to ask ourselves, what's an acceptable maintenance cost for a car? Well, the last one I bought was around £20,000. So we can say the same, dollars or euro or whatever currency you want. It was 20,000. So you can see my asset replacement value, if we took that as the same today, is 20,000. So it's kind of replacement value you'd find maybe on an insurance document with a business. So if the salesperson at the time had said to me, oh, before you buy this car, you're going to have to spend 10% of its value a year on maintaining it, I would have been shocked at £2,000 or euro or dollars a year. But if he said, well, it's going to be about 1.5% or £300, then that's more acceptable. So why shouldn't we ask the same about our assets in a business? There's more value in assets in a business. So if the business has this double figures percentage points in what they're spending on their assets, it's bad news. But the good news is we've got a really good target to go out to make some savings. It's not unusual to have $1 million plant or $1 million piece of plant within a site. So if we look at that and say it was 10%, the CEO or the site leader would probably bulk at $100,000 to maintain it every year, year on year. But obviously, if we said, well, it'd be £15,000, then that would obviously be a lot more palatable. And if you then extrapolate and say, well, we're going to save $85,000 a year, year on year, while we maintain this level of carve, then obviously that can only be good news. I'd like to end by highlighting the importance of people and collaboration. So without these, we can't get anywhere with making the necessary changes. To reduce this maintenance investment, if that's what we need, as the title suggests, it's a conundrum. It's a balancing act to get the best out of our investment, out of our people, and out of obviously the budget we've got. I'm sure it's something nearly all organisations struggle with and probably look at trying to reduce over time. It is possible to turn around. It's a journey, but all journeys have to start somewhere. I've witnessed this firsthand. It took some years. It didn't take months, but the rewards are multiple. And as you know as well, or just said, they are year on year. So you keep on reaping these rewards year on year. The best thing I ever saw, this is another piece of information I've got that's a real experience, is an operations manager and an engineering manager actually seconded each other's functions. They swapped roles for a whole year. The engineering manager had to learn the constraints of the operations manager and vice versa. It was a fixed period, so they knew they were going to return to their roles after a year, and that was the best thing that ever happened to the onset of this strategy, because they both took away what their colleagues' issues were, and then they were better placed in the future to operations say, yeah, I understand the value of engineering, and vice versa. Engineering say, yeah, I understand the ramifications of this on operations. So many thanks for listening. Hopefully it's some food for thought, really. It's not an easy subject to action if you're at the sharp end, I know, but it's part of the reason lots of businesses stick with their status quo. They're stuck with what they've got. So thanks again, and goodbye.
Excellent. Thanks for that presentation, Andy. And we had a few questions. It looks like one from our friend Bob Latino, which you might have typed something in there, but
Yeah. I tried to answer them. So yeah, the correlation between reliability and safety came from a couple of studies actually in the US and North America, and they were over a time frame of nearly 5 years. They showed that when you had high incidence of reactive work in the plant, so those kind of going into double figures percentage points of reactive events, um, the safety scorecard plummeted. In other words, people had more accidents, and they found out that there was less near misses reported as well. Whereas as the plant became less reactive and more reliable, so people didn't have to interact with things that were going wrong, the safety scorecard went up, and people had less accidents, and there were more near misses reported. The other thing that I've been looking at as well, because I looked at that and thought, well, is there any other evidence of this? And I looked at some of the stuff that we do in the UK about the health and safety reports from the Health and Safety Executive. And they showed as well that people working on night shift and 12-hour shifts, the last 4 hours of a 12-hour shift, whether you're on days or nights, was the period of time where people had the most accidents. So there's lots of things you got to think about when people interact with assets, especially when they're going wrong. So in other words, it's unexpected. The risk level goes up. I've seen that personally with people interacting with ovens. So if you've got an oven that's running at 260 degrees C, and that goes wrong, and you need to change a belt or a bearing, all of a sudden you've got 3 engineers around it with asbestos glove, waiting for the temperature to drop down below 150 degrees C, so they can go in there with their permit to work restrictions and start working on it. And it's an accident waiting to happen. So yeah, if you go out and look, you can find that evidence.
It's interesting about the stats with the you talk about people, and if the last few hours of a shift, having that increased rate of accidents.
I know when I first found out about that and read it, I made sure, because I work 12-hour shifts, nights and days, on over a 7-day pattern, and I would always make sure the inspections I did condition monitoring wise, if they were more involved around extruders or ovens, I would do those in the first part of the shift, and I would err on doing all of my data capture information and all the things I had to do in the office kind of after 2 a.m. in the morning before we finished at 6. So I would always err towards doing the more the safer stuff later on in the shift pattern.
So going back to your first slide, 80% of maintenance issues are reactive work, right? Or time associated to maintenance is reactive work. If and I want to start this journey to control the chaos, right? As you put it. And I'm at the C-suite level. Where do I start? Or I'm mid-management. Where do I start? Or on the front line, where do I start?
Yeah. Well, first, if you are at that C-suite level, you've got to know about these things before you can take any action. And that's the biggest step can be taken by getting this information to the C-suite level. And that's always the big challenge. How do you get this piece of news to somebody that probably hasn't got a lot of time for engineering and maintenance? They consider it as an on cost. You've got to make partnerships and alliances with people from operations. And as I said in my presentation, the best thing I ever saw were the changing of 2 roles. They were seconded, and the operations manager and engineering manager had to take others' roles on for a year. And the site leader supported that completely. The site leader understood we were in a period of change, and that change was good. The thing within PepsiCo is they understand that the change is good. If you don't change, then everything stays the same and you get no added benefit. So we made a concerted effort, and it took 5 years to get from that chaos plant where we thought we were under 10%, but when we had a third party visit, they got us over 10% of our budget was being spent. The car value of the plant was being spent purely on maintenance and support. There were lots of things within plants when you go and visit them. If you ask the questions, the maintenance spend starts going up. So if you start asking the question about how do you pay for contract labour to come in, or how do you pay for a specialist to come in, you'll often find people have pushed it to a different budget to hide it.
So you're unraveling the true maintenance costs of these.
It's the bit I said about KPIs. Once you set a KPI in motion and say, well, our aim, say you say it's 5%, we want to spend 5% or less on our total maintenance budget, people are driven toward fulfilling the KPI. So if a human can find a way of getting their KPI so they get their end of year bonus, they will find a way of frigging that figure, sorry for the language, but they will find a way of manipulating that statistical figure to get the money from a different budget. And I've seen this go on where things that were definitely engineering based were pushed into a capex, say. So somebody raised the capex to cover that engineering spend. Those types of things go on. So people, they like to believe myths about where they are.
Right. We love the contribution from our friend Bob Latino. So he's talking here about regulatory work time restrictions on certain occupations that we all know about, right? Can't do legs more than 16 hours, and but he's quite rightly, nurses work amazing shifts, like double duty shifts for 3-4 days in a row, right?
Yeah, I would use the word dangerous rather than amazing, to be honest. I've got a big thing. I've got experience of working those 12-hour night shifts, day shifts, swinging over a 4-day pattern, 7 days a week for 21 years. And prior to that, I did 6 years full-time nights. I survived better on full-time nights because my body didn't have to keep swapping around. And I think when we look in the future, we'll look back at night shift work as kind of like smoking or heavy drinking. It has a big as impact as being a heavy smoker or an addict addicted to either some sort of drug or alcohol abuse. It's amazing the effect that forcing your body to ignore its natural cycle has. And also I've seen this in industry where people have been brought up and management have tried to discipline them for nodding off at 3 a.m. in the morning. And you have to go and defend people and say, to be honest, this is like going to the toilet. People's bodies will break down and they will nod off at 4 a.m. 4 p.m. and 4 a.m. are the cycles in the body where it's at its lowest ebb. So it is more dangerous working through a night shift than working through a day shift.
So on a personal note, my mother worked for a adult beverage manufacturer in New Jersey, and she worked the night shifts, 12-hour shifts, 6 days a week, and she got into like 3 car accidents driving home. Every time.
I know somebody that was in ICU through a car accident coming into work, and then another colleague who drove straight off the hard shoulder of the motorway on his way home. He'd got a 40-minute commute either way to come to work 12-hour shifts. It's not good. I was lucky. I was only kind of 15 to 20 minutes away from the plant. So, and I cycled as well, so I had to be compos mentis. You can't cycle and start bumping into cars.
And so here we're talking about maintenance being reactive. But we keep coming back to the human factors, right? So, so again, we talked about how do we change this from the C-level side. What about the frontline guy or person? How do they make change?
As applied to what? To carrying over working shifts, or to get from a reactive to a proactive?
Controlling the chaos, right? So
it's definitely a team effort. So if you haven't got everybody on board the bus, you're not going to get to your destination. So you will have people within the reactive community who are very, very comfortable with status quo, and they have to be brought along with the group You have to have some advocates and drivers. Some people are open to change, but not very many. Most people don't like change, and that's the thing you have to do. You have to sell change to people and say, this is going to benefit you in the long run. You're going to have a better working environment. You're going to be less reactive, but you're going to get to do some improvement work that uses your skills as an engineer. So I've had, again, examples of that from colleagues I've worked with that were anti being predictive and proactive, but in the end, they saw the benefit was that they got to work on things they wanted to actually do. The watch out is when you do get there, and it does take months and years, it's not done overnight, the sustaining it is harder than actually getting to the goal. So when you do get to 1.5% unplanned downtime, that then becomes a periodic quarterly target that you are deemed to maintain. And if to maintain that, you've got to have a modicum of luck that your major assets don't have catastrophic failures, and you can't get rid of failures. But you also have to, when you do have those events, you have to understand that they're within the life cycle of the asset group. And you have to say, yep, okay, we have this reactive event, we get over it, we learn from it, we RCA it to death, and we make sure we mitigate it in the future. Or if it's very low lying, we live with it. So if it's a piece of equipment that there's redundancy built in, or there's multiple units, then yeah, we can cope with that. It's always good, obviously, in a plant to have a little bit of leeway as to no bottlenecks. But when you have got bottlenecks, obviously you push your engineering staff towards the improvements to make those bottlenecks disappear. So that's one thing that we used to, that's the thing you can do. When you stop being reactive, you'll open up the availability. And once you open up the availability, you'll then see these bottlenecks that appear within the process that then you engineer out. You make betterments to that.
So it's interesting. So you sort of back to the human aspects of this. The skill set is almost is change management, right? So it's getting buy-in first,
yes.
and then change management.
I would say the journey that I went through, we had it was made up of all what I call time-served engineers. So we're all engineers from different backgrounds in automotive, mainly the coal industry, steel. That found ourselves in a food factory. It's the first time we were in food and beverage, and we had to relearn our way of working. From some guys were pure maintenance engineers, so they liked to fix things that were broken. And I came from a background I wasn't. So I'm a mechanical production engineer. So I like to see things work and flat line and operate as they should do within an envelope. Some would find that abhorrent, but this is what led me towards prediction and condition monitoring and lubrication and control, was that I wanted things to work as they should, not as there's lots of things that affect that. Obviously, OEMs only make assets; they never run them. This is another thing we have to understand. It's no good going to your OEM and saying, "Well, why can't I run this asset in this particular way?" when they don't understand how to run an oven or a fryer for 32-day runs. They don't do that. They build assets for end users to use, and then we have to apply these assets in an environment that might be very hot, very wet, may have people around them that might damage them, who may exceed the envelope. Because straight away, any asset that goes into industry, somebody will ask you to go 110%.
Excellent. Andy, you've tricked me as the moderator. I'm so intrigued with everything. We've actually gone over time.
That's good.
Fascinating stuff. I really enjoyed it. You've got a lot of fans here. Thanks so much for sharing your knowledge and being with us today, Andy. Thank you so much. And thank you all.
Yeah.
Cheers all.
Bye.